Hi, I'm Jen. I'm a registered dietitian, but I have a broad background that started out in early childhood and extends into neurodevelopment and then learning across the lifespan. And this is my third video, but my second video was really sort of it became a two-parter. So my first video I addressed um, some of the problems with using AI for health information. Um, I definitely think that's a place where I'm going to be doing more videos. In nutrition, I think I spend half my time debunking misinformation. Um, and so I did some of that in the first video. And as I was doing that, I realized it's going to be helpful to give you a brief review of the science on why I asked the question that I did, why I thought that AI was going to give me the wrong answer, which it did. And I want to give you the actual science of why protein is not energy for all of the cells. So let's get started. This is just a very general overview of why protein shouldn't be seen as fuel, which is a common misconception these days, right? So I asked AI um, if protein was the fuel for all the cells, and it said, "Oh, heck yeah. What a great question. Smart you." And so I had to correct it. Because protein is not energy for all the body's cells. So let me show you why. You should be seeing one of the most basic amino acids. Up here in the left corner is glycine, which is a central carbon, an acid group. This COOH is an acid group. And then the NH2 is the amino group. The hydrogen coming down is always going to be there in amino acid, but then up here we have what's called the R group or the mystery box. And in glycine, it's just another hydrogen, which makes it the most basic little amino acid. Proteins are made up of many, many, many amino acids. It could be small chains in a peptide. So then maybe you got 15 amino acids, or it could be thousands of amino acids in some of the most complicated proteins in the body. So protein are unique because they have this nitrogen group. And nothing in our energy pathway uses this nitrogen group. So, in order for protein to flow through the energy pathway, this nitrogen group has to be removed. And nitrogen, when it's taken away from amino acids, becomes ammonia, which is toxic. So, if I were to give a muscle cell some amino acids for energy, first of all, they don't have the capacity to remove this nitrogen group. Second of all, if they did have the capacity to remove this nitrogen group, they'd be left over with ammonia, which is toxic and would destroy the cell. So, the body cells, for the most part, will use carbohydrates for energy. Under here, the glucose molecule is the most used carbohydrate for energy by the body's cells. Every carbohydrate is carbon, hydrogen, and oxygen only. There's no nitrogen. And all of our cells have the capability of beginning to break carbon hydrogen bonds through various pathways. There is glycolysis and the citric acid cycle. So I'm not getting into those, but this little guy flows through those energy pathways to give us energy, every single cell. Um, Muscle cells and other body cells, but not brain cells or kidney cells, can also use triglyceride. Triglyceride has carbon, hydrogen, and oxygen. This R group, that is not the same as the R group over here. It just means that the chains of carbon go on at different lengths. So only carbon, hydrogen, and oxygen in a triglyceride, and only carbon, hydrogen, and oxygen in a glucose. Triglyceride has tons of hydrogen bonds in these little chains that are R chains. And so this guy is way more energy dense. And it makes it a good energy source for cells like muscle cells because they go through stints of needing bursts of energy. So having a compound with lots of hydrogen bonds available makes this a nice explosive fuel for a muscle. Um, so you can see carbon, hydrogen, and oxygen in a carbohydrate or a triglyceride. Those are fuel for every single body cell. Amino acids and proteins are not fuel for pretty much any body cells. There's a few really in-depth exceptions. We're not going to go into those. So in the general knowledge on the internet and with every like non-dietitian nutrition advisor out there, they're like, oh, it's all about protein. Let's make it protein and your diet should be protein. And your body's like, what? No, 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 that's not going to work. So if you have this super high protein diet, you people are like, I'm on the keto diet. I'm not dead. And you're right. You're not dead because the body's amazing. It's amazing. And we do some really weird things to it and it still rebounds. So, a high protein diet isn't good for you, but the body can acclimate because when you take in tons and tons of protein, extra protein, amino acids, I should say, are picked up by the liver, and the liver can take this nitrogen off. It becomes ammonia. The liver has an enzyme to package that ammonia with water molecules to create something called urea, which is still basic and a little bit damaging, but it's not nearly as basic and toxic as ammonia. So the liver makes the urea and shunts it off to the kidneys to be excreted, and it takes the leftover carbon skeletons and has the capacity to turn those into carbohydrate for you. So it's an expensive process in that it creates a high load of urea production. It dehydrates. It can be inflammatory if you do it to the liver for too long, but you can live on a high protein diet. It just means that you're asking the body to take the proteins apart in the liver and build them back into carbohydrates to be put out into the blood supply to provide energy for the rest of the body. And although we can do this, we should make sure that people understand that we're not using protein for fuel. We're taking the protein apart and turning it into carbohydrate, which the cells then use for energy. It's an expensive process that over time can damage the liver and the kidneys. And it's an expensive process metabolically in that the body interprets having to take protein and convert it into carbohydrate as a starvation metabolism trick. So, from a historical perspective, we were not taking protein apart and turning it into carbohydrate because we had high protein diets 1,000 years ago. We were taking proteins apart and making them into carbohydrates when we were starving. So the body still interprets the deconstructing of proteins and turning them into carbohydrates in the same way. And so high protein diets trigger a pullback in metabolism. The body says, we are starving, even if there's plenty of calories coming in. And it ratchets back non-essential activities like healing or producing antibodies. So, although you will see people get by with their energy when they're on the high protein, low carb diets, what they don't realize is that in the background, their skin cells aren't turning over as often. They may be more susceptible to colds. They are disrupting their own hormone production because hormones are made from proteins. So I think it's good for everyone to understand. Protein's a structure. It's a building block. We use it to make things. That's why 10 to 25% of calories should come from protein. But when it comes to energy, the body is set up to use mainly glucose, so 45 to 65% of calories from carbohydrates, and then some triglyceride for those bigger bursts of energy, about 20 to 35% of calories. I hope this helps and has answered some questions. I'm sure it has generated more questions. So send them to me. I'm happy to answer them. But take this information and think about it a little bit. Maybe watch the video again and ask the questions. See if it changes the way you think about protein a little bit. See if over time you start to recognize that the balance of calories at 10 to 25% protein, 45 to 65% carbs, 20 to 35% fat is set at a way that makes the body feel its best and have good energy and be able to optimize things like antibodies and hormones and skin turnover and things like that. Integrate it and see if it doesn't change the way you look at food a little bit. All right, I will see you in the next video. Take care.